Okay, so we have performed the initial simulation from our previous video. So now we are going to proceed with the optimization process. Okay, so our aim for the new output for our simulation is to improve the gripping effectiveness. So as described previously, the gripping effectiveness can be improved by increasing the geometric advantage, or the GA value. The GA value is computed by dividing the gripping displacement with the actuation displacement. So based on the loading configuration provided to you earlier, the gripping displacement is the direction of the gripping as indicated in the blinking red arrow in the figure on the right side of the screen. So therefore, our aim for this particular criteria is we want to maximize the x direction of the displacement. Okay, now the second output that we want to control is the stress limit. So let's say the allowable stress limit for the polyoxymethylene material is limited up to 15 megapascal only. So therefore, in our simulation model, we have to make sure that the maximum stress limit, either in tension or in compression state, must not exceed maximum limit of 15 megapascal. Okay, now that we have defined the target objective of our simulation model, the next step is we have to look into what are the design parameters which we can control or which we can modify. So in this case, given in your slide is that only position P2, P3 and P6 can be adjusted. So if you recall, the design profile of the flexible gripper is defined at 7 points, which is labeled as P1, P2, P3 until P7. So based on the figure given to you, only position P2, P3 and P6 is allowed to be adjusted. The adjustment range usually depends on the manufacturing process. Okay, basically, it is determined from the limitation or the capabilities of the machine to fabricate that particular profile. So in the case of this flexible gripper, the allowable range of adjustment for point 2 along the y-axis is to be plus minus 10 mm. At point 3 along the y-axis is plus minus 20 mm. And finally, the adjustable range within the y-axis at point 6 is plus minus 5 mm. Okay, now the fun part begins. Alright, in your workbench, we are going to define the parameters that we are going to optimize. So recall from the previous slide that in the design parameter, there are 3 points that we want to optimize, which is point 2, point 3, and point 6 along the y-axis. Okay, now in order for you to optimize that particular parameter, we are going to go to the geometry model. Okay, double click geometry, and since you will start up the design modeler, and then you navigate to the XY plane and you highlight the sketch. Okay, the sketch will show the details of the design points lah. So P2 along y-axis is reflected at this point, which is point V7, right? Vertical point 7. So since we want this parameter to be optimized, so you navigate in the sketch details, and there are one empty box next to the V7. So you just tick or enable that particular box. Okay, so by default there will be a small p activated in that empty box. Okay, so that small p indicate that this is the parameter that you are going to optimize. So you can rename this parameter as y2 to indicate that this is the y direction of point 2 of the flexible gripper. Okay, so you repeat the same process for point 3 and also for point 6. Alright, for point 3 in the y-axis, it is defined as a V7 in your design model. So you tick that empty box and you rename the parameter as y3. Alright. Finally, the y-axis of point 6 is reflected as V13 in your design model. Okay, so accordingly, you tick the empty box in V13 and rename the parameter as y6 to indicate that it is the y-coordinate of the 6th point of the design profile. Okay, now that it's done, you can close up your design modeler and go back to the project schematic of the ANSYS Workbench. Okay, now you notice in the project schematic diagram, there's a new block being established, which is the parameter set. So this parameter set is the 3 points that you have defined in the geometric model, which is the point P2, P3, and P6. Okay, so now we are going to define the optimization parameter for our output. Okay, so we have defined earlier that we wanted to achieve a maximize x direction displacement, and the second output is that we want to ensure that the maximum and the minimum stress is up to 15 megapascal only. So to define the optimized parameter for our output, we have to go into the ANSYS mechanical window. Okay, so you double click model and ANSYS will start the mechanical feature for you. So the parameters for the output is located under the solution branch. Okay, so under solution, you locate for directional deformation. Right, under the details of directional deformation, you locate for results. Okay, and then you see there are a maximum and minimum value. So just the same as the previous practice, you tick the empty box next to the maximum value to enable that particular parameter as your optimization set. As for the second output parameter, again under the solution branch, you locate for beam tool, open up the beam tool tree branch, and then in the minimum combined stress, you highlight minimum combined stress, and in the results, you enable the parameter set for the minimum value. Okay, so why minimum value? Because you want to make sure that the minimum value does not exceed 15 megapascal. All right, accordingly, you highlight maximum combined stress, and this time around you enable the parameter set for maximum value. Okay, once that is done, so basically you have defined all the parameters set for the output of the simulation, so you can close up mechanical and go back to your project schematic in Workbench. Okie dokie, now we are going to explore the parameter set for our optimization process. Okay, you just double click the parameter set and it will open up a new sheet. Looks like the Excel worksheet lah. On the upper left side are all the parameters which you have selected earlier. So there are 3 design parameters which you want to optimize, and also 3 output parameters that you want to control. So if you refer to the upper right side of the worksheet, you can see the details of the design points that you are using in your current geometry. So if you are to scroll further right, this will show the results of your simulation, which include the displacement, the minimum stress, and also the maximum stress value. Okay, so you can control the width of the column just like a normal Excel file like this. And now we can manually enter the different combination of the design points in this particular table. Okay, so for example, if I wanted to test out a different combination of parameter, okay, for example, the first design point 1, okay, Y2, instead of using 40 mm, probably I want to use 45 mm distance. Okay, so Y3, I wanted to use up the 110 millimeter, and Y6 I wanted to use a distance of 57 millimeter. So these are randomly selected points, and then as you can see on the output, you see some lightning thunder. It means that it is not being computed yet. Okay, so if you want to test out different combination of design points, it's also allowed. So let's say I want to add another combination of design points. For example, the second design point is a combination of 47 millimeter, 125 millimeter, and also 62 millimeter. And finally, I want to add up another design point, which is 35 millimeter for Y2, 105 millimeter for Y3, and 60 millimeter for Y6. Okay. Okay, now if you look at the output column, you can see this lightning symbol. Again, it simply means that that particular combination of design points is not being computed yet. Okay, so how do you want to get the results? You simply navigate to the upper left side of your interface and you click on the button of update all design points. So you just sit back, relax, and wait for the ANSYS to compute the different combination of design points for you. Okay, so it's quite easy. As you can see, you don't have to go back to design modular, modify the design points one by one. You just have to optimize the different combination in the parameter set table. So it's as simple as that. I'm just going to speed up this part. Okay, so you will know that the ANSYS have computed all the combination of the parameters for you when the output column is being filled with appropriate results like this. Based on the results that you get, so you can evaluate and decide on which is the best combination of design points which you want to include in your primary geometry file. Okay, so this is actually the first method of optimization by which you are inputting random values in the optimized parameters. If you notice, if we randomly input the design points as in our previous method, we can't really control the output of the simulation results. Okay, so in this particular method, we will look into how we can also optimize the outputs while inputting the range of input into our design points. Okay, so in order to do that, let us just exit the parameter set and let's go back to the project schematic in ANSYS Workbench. So now you look out for the design exploration toolbox and you open up the tree and look for direct optimization. Okay, so you drag the direct optimization module under the parameter set, or you just drop it at nearby the parameter set area. So you will see a link connecting the parameter set to your direct optimization parameter. Okay, so this to indicate that the parameter that you have defined, the optimization parameter that you have defined earlier, are now being connected to the optimization tool. Okay, now you'll just double click the optimization tool and the optimization work area will pop up. It looks like an Excel worksheet, just like the parameter set option. Okay, now you highlight optimization and you look at the lower end of your interface, you'll see the properties of the optimization. So under the optimization section, you look out for method selection. Okay, you change the method selection to manual. Okay, so just below the method selection, look into the method name. The method name actually indicate the optimization method. Okay, so this optimization method is the mathematical algorithm being adopted to select the best parameter which suit the target objective. All right, so you can see there are NLPQL, which indicates a nonlinear programming by quadratic Lagrangian, adaptive single objective, adaptive multiple objective, MISQP, and so on. So basically, it's the indication of different method, different algorithm, different mathematical method to achieve product or structural optimization. Okay, so in our case here, we are going to select NLPQL because it's quite simple and it is one of the most classic optimization method. All right, so after completing this exercise, for your project, you are required to try out for other methods and explain what is the difference between each of the methods being selected. Okay, so for our next step, we are going to define our target and objectives lah, basically. Okay, so if you recall from the earlier slide, our simulation target is the first one. We want to increase the directional deformation. Okay, we want to measure the increment of the gripping direction, which is along the x-axis. Okay, the second thing is we want to make sure that the maximum stress, either in compressive or tension state, is limit up to 15 megapascal only. So on the upper side of your interface, you select objectives and constraint. Okay, so on the right hand side of your interface, a new table will appear. So this is the area where you are going to define the output that you desired. Okay, here under the parameter column, you click on the drop down icon there and you select directional deformation, okay, along the x-axis, this part. So the next thing is you need to define the objectives of that particular parameter. So in this case, we want to have a maximum value. So you choose the objective type maximize. All right. So about the constraint, is there any constraint? No, there's no constraint, so you just select no constraint. Okay, so the next simulation result that we want to achieve is the stress limit. Okay, so again in the parameter column, you choose minimum combined stress value. All right. So in the objective type, okay, there's no objective. We do not limit the value of the stress, but there are certain constraints that we want to impose on that parameter. Okay, so under the constraint column, under the type, you click on the drop down icon, and then you choose value must be higher or equal to the lower bound. So in this case, what is the value of the lower bound? So the lower bound would be negative 15 megapascal. Why negative? Negative indicates a compressive state at that particular area. So we want the maximum stress, either in tension or compression, to be less than 15 megapascal. So if in compression state, then the lower bound will be negative 15. Okay, so accordingly, you have to add on another parameter that you want to optimize, which is the combined stress, the maximum value of the combined stress. Okay, so similar with the previous parameter, the objective says no objective, but you want to impose a constraint whereby the values of the stress must be less or equal with the upper bound. So in this case, the upper bound, the maximum stress value would be 15 megapascal. So you key in 15 here. So positive 15 means that that particular area will be in tension state. Okay? Okay, now we are going to define the range of our design points. Okay, so the design range can be located over here. Okay, this one is for Y2, this one is the parameter for Y3, and this is for Y4. Okay, so now we are going to define the range for our design points. Okay, so for the first design point, which is Y2, you click on Y2, and at the lower side of the interface, you need to key in the lower boundary and the upper bound. Okay, so based on the figure given on the right side, the boundary for P2 is plus minus 10. So therefore, the default value is 40. So for the lower boundary, 40 minus 10 will be equivalent to 30. And for the upper bound, 40 plus 10 will be equivalent to 50. So you key in that value into the lower bound and the upper bound column. Okay, dah nampak kan cara dia? So the next point, which is Y3, you can do it accordingly lah. Okay, so select Y3 and define the lower and the upper bound. So the default value for P3 or Y3 is actually 120. So for the lower bound, 120 minus 20 is equivalent to 100. You key in 100 here. And for the upper bound, 120 plus 20, it becomes 140. So you key in 140 there. Alright. So as for the next point, sama juga, repeat the same process for Y6. The range is plus minus 5. So for the lower bound, 60 minus 5 is 55. And for the upper bound is 60 plus 5, it will be 65. Okay, nice. Siap dah semua. Okay, now in order for you to get the results, you navigate to the upper right side of your interface. You just click the update button. Okay. So ANSYS Workbench will start the simulation for you. So it may take some time for it to compute all different configurations that you have defined earlier. So you can just sit back, relax, chill, layan Naruto setengah jam ke apa while waiting for the results to come out. Okay? Okay, when the optimization process have been completed, okay, you scroll down this table of schematic diagram, and probably you see like a list of 20 design points have been computed by the system. Okay, so how do you want to select the best possible design points which achieve the target objective that we spelled out earlier. Okay, so over here you scroll down, look for candidate points under the results. You click on the candidate points, okay, and Workbench will list out the top 3 candidate points that you can select, which gives the best result as per your optimization criteria. So if you look at the results column here, okay, so any results with 3 star here indicate that it is highly recommended by NSYS. Okay, so basically all top 3 points have 3 star on it. So you can choose either one which suits the criteria that you need. So probably in my case, I wanted to have the highest directional deformation, highest gripping effectiveness. So in this case, probably I would choose candidate point 1 as my primary parameter because it have the highest displacement value of 58 millimeter compared to other combinations of design points. Okay, so as for the combined maximum and minimum stress, both way it doesn't exceed 15 MPa, so that's cool with me. Okay, so in this case I'm going to choose candidate point 1, which recommended the Y2 value of 30 mm, Y3 value of 100 mm, and also Y3 value of 55 mm. Okay, so now we are going to insert these design points in our primary design. Okay, so you just right click this particular row and select insert as design points. Okay, so you can close up the optimization tab, go back to your project schematic diagram in front of the workbench, and you double click parameter set. So if you look into the parameter set, it will create a new column under DP 4. Okay. Okay, so in the DP4 row, you can see that the results showed that the data is not being updated yet. So quite simply, you right click that particular row and then you click on update selected design points. Okay, so this would take very quick, and by default it will regenerate the data which have been computed earlier. Okay. Okay, now if you want to insert this particular design points in your current geometry model in the NSYS workbench, in the design modeler, okay, quite simply you just right click the row and then you select copy inputs to current. Okay. Okay, so now you can see the first row, which is the design points of the current model have been updated to the design point 4, which we have selected just now. Okay, but you notice dia punya output tu ada that lightning symbol. It means that you need to update the data once again. Alright, kena repeat balik. So you just right click, update selected points, and just wait for the system to calculate the results for you. Okay, when that is done, you can close up the parameter set. Okay, you go back to your project schematic diagram in Workbench, and then you activate again the design model to check whether the geometry has been updated or not. Okay, so you double click geometry, and if you look at the sketch now, the sketch has been updated with the new design points that you have selected in the parameter set. Okay, you see, benda tu is quite convenient, and you don't have to go back to design model, modify, rerun everything again. You just do all the optimization process in the optimization toolbox and also in the parameter set toolbox. Okay, let's close up design modeler and recheck our results in the simulation results. Okay, you double click results and you highlight the directional deformation tab, and you will see that NSYS will showcase the new results based on the new design parameter set which you have selected during the optimization process. Okay, so previously the direction deformation is 52 millimeter maximum deformation, but now the new result showed an increased directional deformation of 58 millimeter. Okay, they already show the updated results. So if you calculate the geometric advantage value, the GA value, you will also get a higher GA value compared to the previous model. So higher GA value indicate increased effectiveness, increased gripping effectiveness. Okay, so which fulfills the aim of our design optimization. Okay, so accordingly, if you look at the minimum combined stress, the minimum value does not exceed negative 15 megapascal, so minimum is negative 30, and the maximum combined stress also does not exceed 15 megapascal. So it fulfills the objective or the criteria that we have defined in the early part of our module. Okay guys, so basically you have performed the optimization for a flexible gripper and also for a triangular plate. Okay, there are two different methods that you can explore. So what you need to do now is to submit the report of your exercise in the ULearn as an evidence of your participation for this particular session. I'll take that as your attendance lah. Okay, so till then we'll see you in the next module. Bye bye, see you later, alligator.